So my name's Harry, and I am the CEO of Phasio. So I'm here with Frank Lucier from Dyndrite, and in this presentation we're going to be talking about the integration between Phasio and Dyndrite. Do you want to say a few words, Frank?
Hi, this is Frank Lucier from Dyndrite, and I'm product manager for MJF Pro.
So essentially, the goal of this integration is to ensure an end-to-end workflow from the moment a request for quote comes into the manufacturer to preparing a build and getting a tight nest, sending the build to the machine, and then tracing that entire production process from start to finish through the production floor. So we're going to start this demo on the basis of exactly that, way at the beginning in the request for quotes. So I'm going to start by going to the quote screen and sending out a new quote to a customer. And I've got some parts here which we've prepared in advance. I'm going to go ahead and I'm going to upload them. As soon as you upload the part, Phasio is analyzing the geometry of them to identify whether or not the parts are manufacturable, and it's also identifying whether it's seen these parts before. So as you can see, it's marking this as exists in library, meaning it has actually seen these parts before. And this is going to be very important to some of the manufacturing conditions that we're going to be going in later in this video. But for now, we're just waiting for these files to appear here. You can see we get a quote come out along with each file, the line items here. And when we're ready, we can go into these parts and we can configure them to have the specific manufacturing process that we want to produce the parts in. In this case, I want to manufacture them in multi-jet fusion, and I'd like 25 of each of them. And we're going to copy that to all of the parts. So every part here is being manufactured with a multi-jet fusion, PA12, and we're going to have 25 of them each. And you can see the price is varying on the basis of the geometric complexity. So I'm going to go ahead now, I'm going to create that quote. And this quote is essentially now in the inbox of the customer. So the customer can see what does it cost. There's automatically been the accounting system has been updated, and the customer can either send through a purchase order or they can pay directly within that email. In this case, let's say the customer sent through a purchase order, and we can just attach our purchase order number here so that this turns the quote into an order. And when we do so, we get this new production tab here. The production tab is essentially determining the traveler for each of the parts within the manufacturing facility. So we can see that for every one of these parts, the workstations that they need to move through are exactly the same. So we've got the parts to be downloaded, parts in nesting, waiting for production, multi-jet fusion. This is a classic multi-jet fusion workflow. And what we're going to do is we're going to go ahead and we're going to allocate a work order for this entire order. So we're going to have 25 of each of these parts. So they've been sent into production. But before we start on actually sending these parts into production, there's something we need to think about, which is how are these parts going to be oriented in the builds? So on the multi-jet fusion, it's very important that firstly that you select a orientation which is going to result in the best, the optimal physical properties for the part, but also that the part is consistently printed with the same orientation. Because obviously if the customer is ordering a lot of parts over time, we want to ensure that they're always getting the same properties in those parts. So I showed you before that Phasio remembers the parts that you've uploaded before. So we're going to go into this specifications screen here, and we're going to click on part 9 here. This is the part that we're going to be orienting. In this section here, manufacturing constraints, we can add a manufacturing constraint, and in this case, I'm going to do a rotation about, say, the x-axis of 45 degrees. 45 degrees there, right there. So this part will always be manufactured at an angle of 45 degrees, at a rotation of 45 degrees about the x-axis. And so that constraint is now fixed onto this part. Okay, so that concludes everything from the sales side of the business. We've figured out how we actually want to make the thing, how we actually want to constrain the part. We've processed the quote, we've processed the order, and the order is currently sitting on the order Kanban here at the beginning of its progress indicator, and we now want to send the part into production. So this is where the operations of the production team come along. So if I go into the planning screen and open up the backlog, and we go into the parts to be downloaded step. Let's see what's in here. So underneath PA12 here, we have all of the parts which we want to prepare. These are all of the parts which I uploaded before that formed a part of that work order. So when we go into the parts to be downloaded screen, we can see that under parts and nesting PA12 here, we have all of the parts which we want to actually pack into this build. So what we want to do is we want to download these parts and start preparing a build using Dyndrite. So what I'm going to do is I'm going to click the download button, and I'm going to change the download format to CamSpec. CamSpec is a specialized format which we've designed in collaboration with Dyndrite, and it essentially communicates not just the CAD files themselves, but also things like orientation constraints to the nesting software. So what I'm going to do is I'm going to download this, and I'm going to execute this this file, and we're going to see how this loads up inside of Dyndrite.
So once you go ahead and take that file and push it over to Dyndrite, it actually starts running, is associated with our Python API, and it goes ahead and starts running and pushing the files into Dyndrite. We automatically load the files, and we run the Python script that we've created to specify what we want to do with the files. In this case, we're nesting all the parts, and then we're outputting them to a 3MF file, which is sent back to Phasio to validate the build. And we're also at the same time sending that file directly to our HP command center in the printer. So as you see, we're monitoring here. We've sent the XML print file and 3MF file directly to the printer, and then also push the file back to Phasio for him to validate the order. In the background, what you don't see is we are running this Python script that tells us what to do with the file, the geometry we're bringing in, and then how to organize the file, how to nest the file with what parameters, what printer, and everything. So this is all live. We can edit this, we can modify this, and add variables to do whatever we want to do within the build environment.
So I'm going to go into this parts and nesting section, and you can see that inside of waiting for production PA12, we've got a whole heap of parts here. So there's the parts which we pushed through to production before, but there's also all of these other parts, right? Now, how do we know which parts made it in? For an operator on the production floor, this is going to be quite confusing, trying to figure out whether or not the part made it in or not. Well, with the Dyndrite and Phasio integration, all the production floor operator needs to do is hit upload bill of parts, and then select the 3MF file, and it's going to automatically pull the files over that made it into the build. And as you can see, these are all of the files from before that we wanted to produce. So essentially what Phasio and Dyndrite are doing is firstly sending the constraints and the CAD files to Dyndrite, and then what Dyndrite outputs is a 3MF, which Phasio is reading in and using to know, it's using as a manifest. So we know for certain that these files made it into a build and are now printing on a machine. So let's go into our production tab here. And what we can see is that these two here, the part 9, there's 2 sitting back in parts to be downloaded, and the remaining 23, and in fact all of the remaining parts are now sitting and waiting for shipping. So if I click this, what I can see is the production trace here. So I can see every step that this part moved through. You can see, for example, that 25 was scheduled, 25 moved into nesting, 25 into production, 25 onto the MJF, and then 25 into QC. And then there were some parts that broke away and went straight for ready to shipping, and 2 that were scrapped. And these 2 that were scrapped went into were rescheduled essentially and sent back to the beginning. So that kind of explains the full end-to-end process that covers the integration between Phasio and Dyndrite. So as I said at the beginning, it's all about from the moment you accept a quote to preparing a build, tightly nesting the build, sending it to the machine, and then maintaining an auditable production trace. Phasio and Dyndrite essentially work together to ensure that you have an end-to-end additive process. I would say the first end-to-end additive process that has ever really existed in this industry. So we're very excited to share this with you. What do you think some of the applications could be for the serialization of parts inside of a build?
Well, a lot of customers want traceability. So one thing is medical parts, medical devices. Also, even when you're doing prototyping, you want to be able to do 20 different iterations of a part and label each one to be able to track the outcome in the different changes with different concepts or maybe different designs or thicknesses of a part. Or placement, also placement of a part. You may want to print the same part in 20 different orientations and then later look at what's the best finish, the most accuracy or even strength of a part that's printed in a different part of the build chamber. So you can track that. The GUI interface is a tool for visualization and to also help you build your process. So you can come in here to this interface and mess around with concept of how to build something. But what is unusual and what is very unique about Dyndrite is as you do something, we bring in some geometry. Okay, if we go grab a part. It is actually showing you the Python code right here to import this part. It's showing you the location of it, how you want to orient it, everything about it. So this is the Python code that you would run. So to build a process, you just come in here and in the GUI can run through your process and build the concept. So now that I imported that part, it loaded a specific printer and now it imported that part. As I go through and I want to serialize this part. So I come in here and say, let's add a label. There's ways of automating adding this label to define an area, and then you can go ahead and establish center, location, everything about that label, or you can manually come in and just place that label. If I say I want to place this label on that part here, I can orientate the angle by typing in the field, by changing the size, whatever. The pound, \pound is the variable to numerically label these parts sequentially. And so if I go ahead and duplicate this part, it's going to number them all. So if I want to go ahead and create 20 of these parts, I can control the orientation of that nest, or just go ahead and leave it the way it is and create 20 of them. If we look at it, we just created 20 of these parts and we just labeled them all numerically. So there's the part number and there's sequentially every part labeled. Now if I want to send that to the printer, all I got to do is hit export to command center, send, and it'll send it to the printer. Now everything we've done here has just created a process, which is a Python script that imports the part, adds the label, and then nests the part. And if I sent it to the printer, that would be at the end as well. So the script and what the process that we're building with Phasio is exactly this, the same thing. We can build any process you want. This is the script that imports the part, reads all the information, nests the part, and then exports it to a 3MF and then exports it to the printer.